I got into building clouds inside those data centers. So I probably built more clouds than I care to admit to you. Some were great, some were awful.
Yeah. Deep conversations are coming.
Nice.
Beware. So, dude, you've been building data centers, huge investments, big time production. I want to know everything about it.
Okay, absolutely. So just for your audience, Craig Tavares, I'm president and COO of Buzz High Performance Computing. We're a Canadian cloud service provider. We own data centers facilities in both Sweden and Canada. We operate GPU clouds at scale. We certainly cater to, again, a lot of the sovereign mandates that you see in a lot of those nations, especially Canada, being Canada owned and operated. You know, we have a huge interest and obviously play within the sovereign economy of supporting sovereign mandates for AI. What that means, again, you have to look at the full integrated stack. So yeah, my background, I've been building telecom infrastructure, right out of the gate, right out of school, putting fiber in the ground for communications networks, building telecom companies from the ground up, both nationally and then internationally after that. And when you're in that infrastructure game and you're building all these massive high bandwidth networks, you quickly got into data centers, right? So again, everybody knew that the network and the data center went hand in hand. Like, you can't have a data center without a network, and networks led to a data center somewhere because, again, that's where that information sits. So that got exacerbated when, super hyperscale, when, again, all the AWSs and Azures and Googles came into the market. So I do have to roll back the clock for you a little bit and tell you that continuum, or just go back on that continuum when, again, we went from being a data center provider, and then I got into building clouds inside those data centers. So I probably built more clouds than I care to admit to you. Some were great, some were awful. And then some were right at that cusp when, again, like the hyperscalers came in and took over the world.
Uh-huh.
So the relevant public clouds became what we called, or became what we know as regional clouds. And the regional clouds, the non-AWSs, the non-Googles, still had relevance because one, there was a big customer base that just wanted, again, a simple cloud to access. But more importantly, there was a big customer base that wanted to know where the data was. Right. So again, if I'm going to put my data in a cloud, again, I kind of want it, within, again, a domestic region. And it only is to satisfy, again, certain data residency policies that enterprise or government might have. So again, fast forward, I did some time at some large Fortune 500 companies, went back to venture. I actually did venture where we purchased power plants. So we bought power plants, we operationalized them. These were what we call combined cycle natural gas power plants. And we did that in Canada. And then I built an HPC facility actually directly connected to one of these power plants. So what we know as completely off-grid, a data center powered by its own power source. And then, off the fence, so that the power that I was metering was going directly to my data center. But again, it was my power generation that was supplying electricity to that data center. And that's going back a few years. But now that's what you hear a lot of the big data center companies talking about. They're like, hey, I don't have access to the energy where I want it, when I want it, at the price I want it at. So, how do I scale my data center by creating my own power generation and allowing for infinite scale based on, me controlling all the elements myself, right? Not dependent on the local grid, not dependent on, the region that I'm in, whether or not, again, it has, like, say, renewable energy sources. So again, those are the things that keep coming up all the time. Like you were saying earlier when we were talking, one, what is that basic building block that you have to have first? Well, yeah, it is power and land, right? That's where it starts. Then now I can look at the data center appetite in that market, and then start looking at the data center strategy. So
how do you look at that?
Well, now that with AI, like
there's infinite appetite. You don't have to look at much.
It is like, yeah, because training, when you're looking at model training, again, it really changed the design philosophy, number one, and it changed localization or a geographic relationship. What I mean by that is, again, look at how we built data centers around the world. We built a data center so that the data center is closest to the user. right? So again, I'm building in like key markets, and they're usually large population centers. So as I chose a location for my new data center building, and this is again regional clouds or hyperscale clouds, again, I wanted to be in key markets. And then if you look at the US, we knew these as NFL cities. So if in the US, if there was a state with an NFL team, you could guarantee there was a cloud provider in that very, very first, right?
And for Canada, it's if it has a hockey team.
Yes, actually, no, it is true. Yeah, but we don't actually have a lot of hockey teams, believe it or not. But yeah, no, there are a few key markets in Canada, and you could count them in one hand. But Toronto being the big epicenter, Montreal being another massive market, Vancouver another market, Alberta. Manitoba is coming up as a very relevant market as well too. So yeah, we do see again the growth in Canada. Quebec grew really fast for another reason, is because we had very cheap hydroelectric energy.
Oh,
So
it enabled the build out.
It did, yeah, because one, there was a lot of it. So when Quebec started investing in its power infrastructure years ago, it was to enable industrialization. So they wanted the forestry guys to come in. They wanted the mineral mining guys to come in. So they built lots of hydroelectric energy because, again, those are industries that take a lot of electricity, use a lot of electricity. It didn't really happen. So it didn't actually happen. And again, you were talking about 20 years ago when these investments and the infrastructure development started happening. But one thing that did happen is data centers saw the opportunity, and data centers came in really quickly. So we saw a lot of the consumption and all the power demand really get eaten up fast. And then the other thing that happened too was a lot of battery storage companies that came in from battery manufacturing perspective came into the market too. So again, this is more on the manufacturing side. And to build batteries, there is a huge energy demand as well too. So electricity is a key element in developing batteries. And if you're developing batteries, you're doing it under a green flag, a green mandate. Therefore, you don't want to be creating or developing batteries with fossil fuels. So again, because Quebec was hydroelectric, all the battery manufacturers really enjoyed going to Quebec to use, again, an abundance of cheap energy to do what they could with renewable energy sources.
So I like that you are basically going full stack on the building out of the data center, saying we're going to produce our own energy. We're going to make sure that we have the capabilities that we need. How are you producing that energy besides the hydroelectric?
So today at Buzz, we don't actually build and produce any energy ourselves. What we have done is, and this comes from our parent company, Hive Digital. We've found locations around the world that has that situation I'm explaining to you, where there's an abundance of hydroelectric energy. One, we wanted to really stay and remain a sustainable company where, again, we're using a renewable energy sources, and in this case, again, hydroelectric or geothermal. So Sweden was, again, a big anchor site for us. It was a primary location for us, and where we built some of our first facilities, so that again, we're using 100% green energy there. Again, Quebec, again, another obviously a home base for us, and then a lot of our GPU clusters today that we offer to the market are based in Quebec. And, my parent company, Hive Digital, just made a large acquisition in Paraguay, where we purchased a very large piece of land facility connected to one of the largest dams in the Western Hemisphere. So 100% hydroelectric again.
It feels like if you build it, they will come now.
Yeah, I think you're planning a roadmap. Like you're creating that energy roadmap so that, again, as you build out that data center infrastructure, again, you have the energy to back it up and the energy to scale with you. So again, for what we need to do and cater to the market that we cater to, we're building fully integrated data centers, which means that right now the locations and the access to energy and the hydroelectric energy that I have, it actually caters to demand, and for the next couple of years, it'll cater to whatever I need to do from a GPU cloud perspective. So data centers, come in different shapes and sizes, right? Again, the traditional data center that I was talking about earlier, we were building really sub 10 kilowatt racks. So I could put in any single rack, a bunch of servers, and I could consume up to 10 kilowatts of energy in that rack. And then I think, if you sit any of infrastructure talks here at the conference, you'll hear that shift again, where again quickly people had to go from that 10 kilowatt rack or sub 10 kilowatt rack to a 40 kilowatt rack when the H series GPUs released, right? So you just went kind of anywhere from like 5 to 6 to even 8x, depending what your power consumption in that rack was overnight. And then you quickly went to an 80 kilowatt rack really in like a 3 to 6 month period. And now what we're planning for is 130, 135 kilowatt racks with the GB200s.
With no view of slowing down at all.
I think, again, data center design and data center construction will naturally limit the absorption in the market. If you talk to Jensen, he's already preempting, hey guys, start thinking about 400 kilowatt racks. Yeah, and you get into other issues with that. One, yes, again, power density is a huge problem. You probably have to get out of this rack mindset. So a data center will not be the same data center that you remember it like, a few years ago. And then the heat dissipation is a real issue. That's a real thing. And that's why we had to shift from air-cooled to liquid or water-cooled, because you can't get the same heat dissipation or the same thermal transfer through air as you would with liquid. So again, you're trying to create that thermal efficiency and removing heat off those chips as fast as humanly possible and at scale. So yeah, it's not an easy engineering feat to design data centers, but also design data centers so they're modular and future proof, right? Because again, I'm trying to plan for what that next rack density might be, and they're just getting more and more dense and more power hungry.
Do you see a world where there's 400 kilowatt racks? And how does that look? How do you make that transition, especially when you're trying to plan forward proof and you're like, dude, I just got to 130. Give me a little bit of a rest.
So we have ongoing joke with our engineers is don't screw anything down to the ground. So
put it all on wheels so you can just wheel them in and out.
That's right. So yeah, and if you think about this for a second, like the size pipes we're putting to data centers for the plumbing just to move again liquid fast enough at volume through these servers, I mean it's already massive. So yeah, if you have to now again prepare for the future and say, okay, I need the right plumbing infrastructure in place, I need the right electrical infrastructure in place, these things are just going to get bigger and bigger. So yeah, it's not like, I don't think anyone has actually solved for all those answers, except like I said, like don't get used to one standard. That's why I'm saying don't screw anything down to the ground. Like you could change it next year again.
I remember that I made a joke. Oh yeah, you're in Canada and Sweden because it's cold there, right? And you're like, well, that's kind of true, actually.
It helps a lot. Yeah. So the metric that we use to determine your data center efficiency is something called PUE. So it's like your power utilization efficiency metric. And in most data centers, especially cool climates, we try to leverage what's known as free air cooling, right? So I want to use as much of the ambient air when it's cool, bring it into the data center, use it instead of firing up my chillers, and cool that water loop, like if it's liquid, or if it's just air that I'm putting into the data center, right? Take the cold air from outside and use it. And yeah, in climates like we have in northern Canada, and if we have northern Sweden, again, yeah, you want to leverage that cold air again for 80% of the year. Again, you have cold air. Why not use it? So then that way I drive down my PUE, and on average throughout the entire year, I have what we know as like a 1.3 PUE. So for every 1 kilowatt of usable energy or a capacity to have my server, I'm using about 30% more to cool the environment and manage environmentals within the data center.
I hear a lot of people talking about building data centers in the desert in the Middle East.
Yeah.
Does that just not make sense?
Well, you can do it. You just wouldn't use as much free air cooling. So there are other cooling techniques that you would incorporate, such as evap cooling. Yeah, definitely you might have to fire up the chillers more often, but they're innovating. I mean, even in climates like that, they're always looking at innovation techniques to, again, keep efficiencies really low. And one thing that we see work really well around, what we know as district energy plants is one, if I do generate heat, I want to reuse it somewhere else. So the other thing that we do and we look at when we design data centers, especially if they're industrial parks, yeah, can I take that heat waste and then, hey, give it to my neighbor if they need heat
For a
cooling?
sauna?
Yeah. or anything like that. Yeah.
I figured Sweden.
Yeah. Oh, absolutely. So you whatever you can use that heat waste for, yeah, go create a district energy system with neighboring businesses to reuse that heat. Or another idea, and we've done this historically. Like if you're say near a large body of water, it could be a lake, it could be the ocean, and you have the ability to actually leverage deep lake cooling or deep water cooling. What you'll do is take, again, cold water in from that water source and then run it through your data center. So again, this is another district energy type technique. We do it in Toronto quite a bit. Like all of downtown Toronto, or most of downtown Toronto, is on this district energy system where we take all the lake water, pump it through pipes in all the commercial buildings, and that's how we create the cooling for the buildings.
Oh, cool.
Yeah, same concept for a data center, just again, more dense, more compact way to do it.
So there's a lot of different chip companies here at the Raise Summit. I talked to you about this and you're like, yeah, they're kind of a dime a dozen. They have their different perks, but you are standardizing on NVIDIA, right? You're not doing any other kind of chips. You're not really interested in.
It's true. Yeah, we have found a strong partner in NVIDIA, and we also get a lot of support from NVIDIA too. So they're really big on supporting their NVIDIA cloud partners. We're one of them. So, we're very, very fond of that partnership. Certainly, again, when you look at the NVIDIA team, they're pioneering and carving through, again, new technology feeds, right? They have this innovation engine that's always going. And the thing I love about NVIDIA is they're not afraid also to experiment and get people to come and collaborate and experiment with them in the market.
Are they the ones coming and helping you with the cooling and the design
They do. They have a great team that, again, collaborate to say, hey, listen, we want to build a standard. And the reason why they want to build a standard is they want to create a consistent experience for all the customers. So again, if you're going to spend $250,000 a server, you as a consumer, or me as a service provider, and trying to monetize that, definitely, you want to deliver the best experience to your customer possible, which means performance, reliability. And that reliability is really around uptime, because again, I'm spending lots of dollars to build my AI project. Well, listen, it better, the hardware better work. So yeah, they do have a strong influence. They bring in, as reference architectures that the NCPs use. And listen, again, standardization is not a bad thing, because that standardization can also be updated when you find new innovation techniques to make something better. So it's not to say that you standardize to lock into a rigid framework. It's to say that, hey, once we find a good recipe, let's all follow the process. But when we see process improvements for the next iteration, we'll incorporate those.
Do they also let you know what's coming down the pipe?
Absolutely.
And that's where you can recognize that in the next 3, 6, 10 months, we should also be starting to prepare for XYZ.
Yeah, and it from two angles. One is the hardware perspective, right? Yeah, how do I have to plan my data center design around that new technology coming to the future? It's telling you, again, you're going more dense. And then the second part is software, right? So again, I want to say that NVIDIA equally invests as much time in hardware in their software stack. So yeah, we definitely get early preview of all of these things, and then again, the goal is like, yeah, how do I create like the best AI platform and democratize that for easy access to everybody that's innovating, because we want to accelerate the speed of innovation in the market right now. That's the one thing that we don't want to do, is slow down anybody that again is building the AI project, and they themselves have to get to market really quick because they got to see an ROI and they got to monetize it themselves.
Yeah, this is probably a good point to talk about the hardware, software bottlenecks that you were just talking about on the panel. What are some key points that you've been seeing out there?
On the hardware side, this was more about keeping up with long lead times and supply chains. So, in some areas and some businesses, you got guys that are GPU rich. That means they have open access GPUs, huge budgets, a massive amount of capital. So you see a lot of wastage. You see a lot of unutilized GPUs. But then on the other spectrum, you do have a big part of the market. And again, you see this with researchers, you see this with startups that don't have big budgets. So again, they're a little bit GPU poor. I want more and more GPUs and I love to innovate faster, but the GPU is expensive. It's not cheap. So what we do on the hardware side, again, is we have a planning sort of continuum where, one, from a data center infrastructure perspective, that's probably the longest lead item because it takes a long time to build a data center. We're talking 12 to 18 months in some cases, right? So I have to have that data center pipeline capacity ready to even deploy or install a GPU. And then obviously the GPU itself, again, you have to have alignment with, again, your OEMs, all the server vendors that again are packaging those NVIDIA GPUs. And then when you install them, and we've got really good at this. It used to take a long time to turn up these clusters. They're highly complex. It's like wiring a brain and making it work with 1,000 network connections, and again, all the software
and just
stack
one
and firmware.
plug is not in the right place.
Yeah, no, you got all these errors and problems.
Oh,
yeah,
man,
it sucks.
Sounds like a nightmare.
No, it sucks, right? So again, yeah, but we have, we've got a model down where again we can deploy really quick. But when I say deploy quick, we're still talking about weeks sometimes, right? So again, install the racks, connect it from a network perspective, then commission the servers and then pressure test them, right? So again, that's making sure I get all the right firmwares in there, all the right drivers are in there. And then I got to get the OS and patch properly. And then I go back to test it. So again, yeah, that takes time. It definitely takes time. And then I when I have a clean system, then I put it in the market and then start to monetize it.
And then you throw the software on top of that.
Yeah. And that's the other part of the bottleneck you're talking about. So on the software side, now, as a service provider, what I want to do is offer some level of orchestration to my customer too, to say, hey, number one, let me make sure again, I put you on the right platform for the right reason. And whether you give a customer bare metal or whether again I'm giving him Kubernetes to consume or maybe it's Slurm, it is around again me optimizing that platform for the customer's use. And developers, again, you look at historically, developers love bare metal. The problem with that is, again, you have a lot of, it is, yeah, and you see wastage start to come out too, right? Because, people start to treat servers like pets instead of cattle. And then
that was the whole DevOps movement. Around that.
No, it came back. It came back again, right? Yeah. People are hoarding GPUs, right? People are actually holding on GPUs if they can, because again, you see this cycle, and even the hyperscalers where it's actually hard to get a GPU sometimes, right? And then, unless you're willing to lock into a long-term contract, and people lock into long-term contracts. Why? Because when they need the GPU, they want to make sure they have it. So anyways, it's a behavior that we see in market all the time when, again, there's a resource that's highly desirable, and when you need it, right? So the software stack on this side is one, yeah, we do see optimizations, at least from a model perspective. So you look at, you look at compression, right? Really, really simple things that everybody from a model building perspective always tries to improve. And then you go down the stack to orchestration. That's where, again, as a service provider, now I want to schedule workloads and put them in the most efficient places and to make sure I'm creating maximum usage out of my cluster. Because why? If I have wastage in my cluster, well, I'm not monetizing and making the money I need to pay back the investment.
I was talking to Paul yesterday, and he was mentioning how for him, he's okay paying a premium for a more managed service on this because it's so hard to get talent that really understands how the hell these things work.
No, you hit the nail on the head. And when you go to enterprise, you can't go and sit down with a company and say, oh, how many GPUs do you need? You can't have that conversation. Nobody is going to know how the hell to answer it. Yeah, and no one's going to know what to do with it either afterwards. So again, yeah, that's where, again, I think the token economy is starting to become more and more a real thing. And especially as we start to shift away from guys that are just doing foundation models and really, again, still going back to tune models, because again, you get into a lot of organizations where, again, they're just taking proprietary data and they want closed environments, so they want on-prem environments. So yeah, you will still get a lot of tuning happening, but then again, you quickly shift to that inference side of the equation. And then, now you're abstracting the hardware, which is good. That is actually the right thing to do, because like I said, back to the bare metal conversation that we're having and trying to sell GPU hours or trying to sell bare metal, you do see a lot of wastage there. Right? You can't maximize efficiency very easily because you're leaving it to an individual or someone else and their behaviors to maximize that hardware themselves. And in multi-tenant environments, yes, as a service provider, and it may sound counterintuitive that I want people to save money, because if people are spending money, well, that means I make more money. It's not true. I want people to have efficient usage because, again, it extends the life of the project. I want to add value as a service provider, so my service becomes more sticky as well. So anyways, that it's actually great, again, for innovation. It's great for the industry. And then it's great for my brand, because if I could send you a recommendation and say, hey, listen, look at my tooling. Here's where you have wastage. Here's where you could optimize, or here's where you could be on a cheaper GPU for the workload that you're doing. I want to provide information to my customer.
Are you also renting out GPUs to some of these neo clouds that are just doing inference, like the modals and the base 10s, or do they get enough in other places?
No, we do have a pretty broad customer base, and a lot of them are inference as a service providers. So we do that. And again, those guys are great too, again, because their downstream customers are more interested in, okay, how many tokens am I using, rather than how many GPU hours do I need, right? So that, again, you do see, again, a huge shift in the market, so that, but you still need a metric. That's why the token is important. However, again, like I said, the GPU hour is just really, really inefficient, and it was a little bit more hard to place in terms of me trying to quantify, again, how many GPUs I need for, again, a specific model or a specific project that I needed to deliver.
Well, I know some friends that bought some GPUs, and one of their main decision criterias was the level of support that they were going to get, because they knew it was going to be so hard to just go in there and figure out how to make this work with their project. And there was going to be a lot of learning for both parties, not just the team that was buying the GPUs, but also the folks that were renting the GPUs. There was a lot of times where they were encountering things for the first time. And it's like, all right, well, let's troubleshoot this together, I guess.
So we still see that even as a service provider and operator. Like, again, a new firmware from an OEM comes out and it changes everything. Then we got to roll back firmwares because, again, I'm not getting the bandwidth that I was supposed to get. Or again, like I said, you got to install patches, or you install packages in the right order just to get, again, the throughput you need, because this is around moving data too. If you think about it within a cluster, like, the network has to be operating at full bandwidth efficiency. Your memory has to be at full bandwidth efficiency, right? And, this is where NVLink came in, because, again, you want the cluster to act really as a single server almost, where, again, that GPU parallel processing, again, they could all talk to each other at again, the maximum efficiency. So you go back to what we know as primitives. Primitives, again, are your CPU, your memory, your disk, and your network, right? And then you need that high throughput across all those elements. So again, there's one vendor that we use on the storage side, Vast Data. So again, Vast has been extremely, extremely powerful for us because, again, you don't see bottlenecks to storage, and it's network storage. And then our orchestration, like, we partnered with folks like Rafe, who, again, create massive orchestration automation for us, even at the Kubernetes level, or creating dev pods, for example. And, again, when you talk about customer experience, again, this is where, again, we want to make our customers, easy to consume, or provide the infrastructure our customers easy to consume, or they hit that easy button so that, again, they're not like you said, they're not thinking about it too much.
Yeah, I remember we had Mohan on from Rafe, and he was talking about how they're this middle layer, and it's constantly like the ground is shifting underneath them because there's not a clear thing on how many GPUs are actually being utilized, how much of the GPUs are being utilized, if there's rolling updates happening, which ones are we taking offline, putting online.
Yep.
So underneath them, nothing is stable. And then above them, the demand isn't stable either. It's like, I want 50 GPUs right now. I want 50,000 GPUs right now. And so they're constantly trying to play this game of like cat and mouse on, all right, well, we can connect these here. And it reminds me of my daughter's like little playbook where you draw the line of this is a mouse, and so then mouse word goes there with the picture, and then you draw the line here and it's like this is a cat, and cat goes there, but you're just doing it at a ginormous scale with a lot of money on the line.
I think the best story I can give you is around historical technology evolutions, and I had the opportunity to listen to Jeffrey Hinton in Toronto not too long ago, and he was asked the same question. Like they kind of asked, hey, what was the efficiency gain, or like what was the thing that allowed us to get to where we are right now? And I was surprised, and not so surprised by his answer, but he actually said it was the progression and evolution in GPUs. So it was the advancement performance of the hardware. Because when you look at efficiencies and you look at evolution, you see it across the entire spectrum, hardware and software. So, based on what you were saying, even with Rafe, you do need the software optimizations at different levels, whether again, it's in the model itself, whether it's the orchestration layers, or just be behavior. Like, how do you create more education for people around their behaviors, around usage? But the example that I wanted to draw to is you think about autonomous driving as a technology. It's a solution, it's an outcome, but the technologies behind it were twofold. One is you have that AI, right? AI, making decision. This is almost like real-time inference, by the way, too. But here's a big but. You probably wouldn't have got it, and Jeffrey Hinton's right, without the GPU. Another example of that is OCR. So it's optical development in the camera. Right? So if you think about a self-driving car, well, guess what? If that camera didn't evolve to where it is today, you wouldn't have self-driving cars either. So it is like that convergence of all technologies evolving almost at the same pace, and then reducing or lowering the barrier of entry for that innovation to start. And economics has a lot to do with it too, right? So is the GPU at a price now that I could offer to the market, that the market could finance or manage or fund to go do the things that we do today?
The GPU played a big role in that because of their training. The camera played a big role in that. You have this intersection and this convergence of all these different pieces. And so then when you look at it and you extrapolate it out to the companies and the businesses, now when you're talking about the economics, it is clear that companies need to be able to say, this makes sense economically for us to spend a lot of money on whatever it is that we're doing. And so that conversation is now being had more and more. Are we spending money on GPUs just to do AI, or do we start to see that ROI from it? And I think more and more people are quantifying what is the lift that AI is giving us. We've moved out of that POC phase, and now we're not willing to burn a lot of money on the GPUs just because we want to be AI literate.
Yeah.
And so it's very cool to see.
No. Again, yeah, you struck a chord with me on that one too. And more so because obviously Buzz being a GPU and AI centric cloud provider means that, again, yeah, we have purpose-built tooling, we have purpose-built software in our cloud for the development of AI. But what we've done too is we've offered a product in the market that's a fraction of the cost of like a hyperscale type offering. So again, if you compare us to like the AWSs and Googles and Microsofts of the world, yeah, we are much cheaper to go get that AI project done. We're quicker and more simpler to use. And it allows you to fail fast, right? So when you're in a platform like ours, you could throw pizza dough on the ceiling and see if it works. Again, you're not running too high of a budget, and because of the concept around cloud, well, guess what? I could hit the reset button and start over again. Yeah, if you were to go straight to, I'm going to go buy hardware for my own data center, try to figure out how to use the GPU, figure out if I got the right optimization techniques in there, figure out if I brought the right scale. That's a dangerous venture. Yeah, that's a really dangerous investment. So it's really good to at least start in cloud, get that POV done, see if you could build an ROI really quick. And like I said, you could fail fast. If the pizza dough doesn't stick, well, hey, the pizza doesn't stick, right? So, and then, yeah, once you have that, you may stay in cloud, or you may, and we've seen this a lot. We may create hybrid environments where, yeah, now I do edge into my own on-prem data center. I want to have my own dedicated stack. The economics may work better in that case because I can drive high utilization on that hardware that I own. And then I use cloud for bursting, and I use cloud for different projects, whether, again, it's maybe just my inference platform that I want to run in cloud, and I'll keep training on-prem, or vice versa. So yeah, I think hybrid is a great future for everybody, right? Being able to figure out, again, where the dollar should go based on how much hardware I own versus how much hardware I rent.
The hybrid narrative for the cloud was always something that people like to have, but I don't know if it was ever a really strong need.
Yeah.
Except for a few companies that definitely needed to do it for one reason or another. But at the end of the day, folks like to talk about it more than they like to actually do it. But here, I think it flips it on its head because of what you're saying, where you need it, whether you're trying to get more access to GPUs and you can't get it, or you're just seeing that unit economics work better when I do certain things on my own or with this cloud, and this cloud provides this type of service, so it's better for these use cases. And you have this almost like new paradigm that's emerging where hybrid is very common design.
Yeah, but I want to say one thing: hybrid's not easy to pull off.
Yeah.
So what we've done at Buzz,
which is why I think traditionally people weren't doing it.
No,
they were
right.
talking about it, and it's like, yeah, we're going to go hybrid, or we like hybrid. And I remember somebody telling me that the CEO of Databricks loved it when people would talk about hybrid, because they were like, yeah, everybody loves that idea, and then they end up using us. And
execution fails. Yeah.
It's like, it's a great in theory, but not in practice.
So one thing I could tell you is that, again, when you look at a lot of the AI projects today, we see a lot of data movement. And that data movement happens because, I have all my applications in hyperscale cloud right now. All the data is sitting there. It could be an S3, but I need a specialized platform to do AI. I don't want to pay the hyperscaler price to do it in their cloud. So now you see, again, a lot of data movement happening from hyperscaler to a platform like Buzz. And then, hey, I may train something, I may tune something. Again, I may run an inference endpoint. But what I don't want to do is have to move the data back in. So I don't want to create a movement of data from one place to another, then another place to another. So again, I think that's one thing that Buzz has tried to do, is we've tried to create a holistic platform. It's an enterprise grade platform, which means that I could take something from, again, its infancy, from its genesis, and that's again, maybe again, even building a training model to how that turns into an app and hosts the app as well too. So again, we provide VMs, we provide the storage services, we provide the security services, we provide the resiliency, and really, again, it at least allows a user, a consumer, to not have to move the data back and forth. So you could host everything and run that app in one place. So at least, again, it goes back to what we were talking earlier. Like, I want to create the proper customer experiences. I want to create the proper environment for my base to be able to use my infrastructure without making it too complicated, right? And yeah, moving data is not easy, and it's not cheap.
That's what I've heard, that when folks are going and shopping around for GPUs, a lot of times you forget about that. And then you are starting your project and you're like, oh yeah, egress fees are kind of expensive. We didn't realize that it was going to be this expensive. And if you talk about the hybrid model, there are ways that you're going to have to get really creative with that data architecture so that it doesn't end up not making financial sense again. You're like, you did all this gymnastics to make it hybrid so that you could save a buck here and there, and then it doesn't work.
Yeah, no, it's again, a good point. I think when we look at hybrid, and what we saw traditionally, especially in cloud, was there were a lot of enterprises and companies that preferred to keep certain applications on-prem, and they if they understood cloud and they understood that the best thing to do with cloud is go cloud native, not lift and shifts, then they were able to harness the value of cloud a little bit better. And then it became economically more feasible too. But yeah, everyone that just did a lift and shift to say, hey, I'm going to throw an application in cloud for no reason at all, that wasn't a great idea. And that became very, very expensive. So again, hybrid was more a forced methodology previously, where again, I think some customers that needed to keep apps on-prem did that. And that could be compliance reasons too. Again, it goes back to what I was saying earlier on sovereignty and data sovereignty specifically, where if you couldn't show that, again, your data was in one place and it was secured and ring fenced the way you need it to be, well, you weren't meeting certain compliance and controls that you had within an organization. So again, that really kept, again, the co-location business alive. It kept, again, a lot of data centers that where customers, again, just had their own racks, they had their own space. Traditional enterprise IT data centers that existed, again, those are still there for that reason, right? It's around, a lot of it is around the data sovereignty and the data residency requirements that they need to meet. And then, yeah, you go to hyperscale, and again, they were great front-end apps, so they were great web apps that love to be in hyperscale cloud, and they were suited for AWS, but again, especially if you're using cloud native techniques. So again, come back to AI now, and again, AI loves on-prem, massive amount of data that you got to train. But again, when you go to inference, again, it's not, again, the same data set. However, one thing I'll share with you is why would you create multiple data sets for different types of phases within that AI journey, right? If I have my data in one place, I want to keep my data in one place and I want to iterate on it. Therefore, again, if I have to go back and tune it too, I'd rather not create a second copy of that data. So, yeah, I think you're absolutely right. The concept of hybrid sounds attractive. It's not easy to execute. It's not easy to manage. And typically, if you get everything in one place, you want to do that.
What are you most excited for that's coming down the pipe?
I see. So again, if you look at one sovereign around the world, and what a sovereign mandate is, again, countries and nations, they're saying, hey, listen, I get that AI is super important. I hate to use the arms race term because it kind of refers to, trying to acquire as many GPUs as possible. But the truth is, I think what a lot of countries have recognized is they do have to have an AI strategy. And, for certain countries, that AI strategy means, well, one is keeping a talent pool or growing a talent pool within the country, right? To help businesses to grow your GDP. Yeah, and it's super important because one, you don't want brain drain too, where again, you have your talent coming out your universities and schools just jumping to another country because of a higher paycheck as well too.
Well, and they can't get access to any cool stuff to work on.
Yeah, no, it's a big problem. And then for governments the other big thing behind sovereign, right? Government itself is going to be a massive consumer of AI. So again, they do see it as a strategic position. So you have to adopt AI as government. There's so many government departments and factions too inside of that. But again, what sovereign is really, it's control over the infrastructure, right? Do I have domestic control of that infrastructure? Do I have domestic control of the operations? And that's all digital operations too. And the last one is data. Like that sovereign piece is really a data story. Like, is my data itself sovereign as well? And now you can talk about sovereign AI. And again, the way the government supporting this, and Canada's been great for this, by the way. Like, the first thing we did was we elected like a minister of AI. That brilliant. Yeah, we need a guy that's hyper focused on this, like, fueling innovation, fueling the economy around AI itself. And then we create a grant program. So, that, and you hear about the headlines all the time too, right? Oh, EU just allocated $100 billion to again, data center infrastructure and AI. Saudi, they stood up Humane and, they got another, an X billion of dollars there. And then you got Stargate, where again, they earmarked $500 billion to go build data centers, which again, if you look, under the covers, it's we're going to deploy, the first $30 billion and, this progression.
Ramp up.
Yeah. So, but again, it is a lot of those headlines where you see again investment but it's a stake in the ground too, and countries saying, yeah, no, I get this is hyper important. It's one of the biggest revolutions that we've seen in our time. So yeah, I want to make sure one that the funding is there so that we protect our sovereignty. Number two, that we help businesses innovate and move forward. So again, yeah, data center GPU access isn't the bottleneck or the threshold to go innovate and build.
Is there any other topics that you want to touch on that we didn't touch on?
As Buzz, we've been building enterprise platforms, but we've also started to incorporate a sovereign philosophy and a sovereign framework in that. So when I say enterprise platform, that's going above, again, your basic cloud and AI tooling that you would see to develop an AI project. It's again incorporating very rigid compliance, very rigid security techniques and technologies and systems. It's incorporating high availability, reliability, tight SLAs for our customers, right? And then bring in the sovereign. It's around again adhering to certain national or local policies, and keeping governance and control over an environment. So sovereign actually has become the new standard. And if you say, "Hey, I'm a startup and I don't even care about sovereign," you might be right. You may not need sovereign, but because sovereign is setting a high bar, you enjoy the reliability of that cloud. You enjoy the reliability and performance of those platforms.
So you don't have to sacrifice just to be sovereign.
Correct. Exactly.
Perfect, dude. We got it.